Okay, if you've got a civil model, it's almost certain that you're going to want to do things that are pertinent to civil engineering, and these are what we call the civil tools. And we can do profiles, perpendicular cross sections, so that's a section that will maintain perpendicularity as you go around curves, a simple two-point cross section, or a station and offset. So the important thing here is that your data comes from a proper civil model, could be Open Roads Designer, Civil 3D and so on, and has gone through a civil bridge. Obviously a Civil 3D model could go through a DWG bridge, and an ORD, Open Roads Designer model, could go through a microstation bridge, and you're not going to get much real civil information from that. So let's have a quick look at how this works. I'm seeing all the 3D data in here, and that's fine. You can also view the 2D data if you really wanted to, but this is great. So let's have a look at the profile tool. Here it is. All we do is we pick an element that is profiled, and you can see we will now see the vertical profile here with the radiuses, in this case of my parabolas, the slopes on my straights, and so on. So we can see a sag curve here, and you can see we're getting things like lowest point elevations and so on, all useful information as part of our model. Now it might be that it'd probably be best viewing this from the top, maybe with the perspective turned off. So as I run along this profile, we can see the station or the chainage value as we run along, like so. So that's a profile. So let's have a look at a perpendicular section. So let's look at the perpendicular cross section. Again, I'll click the same data. And now we're seeing our 3D model. So we're seeing this at this point, and we're seeing all the data that's come from our, in this case, an Open Roads Designer template, like so. Not looking like the best design in the world, but let's worry about that later. And you can see as I go round curves, it maintains that perpendicularity. So here we can see the embankments here. And if I had a terrain model on, it would show in here also. I don't in this case. So that's quite useful. I can probably turn on the, let's see if I can turn on the, let's turn on the terrain. That's not the terrain. Let's have a look. Yeah, just turn everything on. Yeah, I'm not finding it in here, but that's okay. So there we go. That's by the way, you can click on this number here and go to exactly a station that you want to. And this can be stretched vertically if you want to. We can make measurements in here if we want to, or we can change the vertical stretch in here if that's what we want to do. If we do measurements in here, normal measurements, of course we're going to get the percentage of our slope in here, and a ratio 1 in 25 and a small amount in here. And if you were to go through the numbers, you'd work those out yourself. So that's quite useful. Let's get rid of that. And again, we'll close this down. Go to a top view. Not sure why the big map came on there. Shouldn't have done. And let's have a 2-point cross section. This is very simple. We just give 2 points and we get a cross section. So you can notice that there's no perpendicularity. We can move this wherever we like, and so on. Okay, simple as that. And last but not least is the station and offset. So if I pick a piece of geometry and I move my mouse, I can, let's do that again. Pick that piece of geometry. You can see as I move around, I can give points. Offset to the left is negative, to the right is positive. So this point is up station this way. And always remember that if you pick a piece of geometry and you go to its properties, it's got the length, the starting station, doesn't always have to start at 0, So you get all the information from that. Be careful with the length here. That's the three-dimensional length. This is the length of the alignment in plan. So going to be slightly different. Okay, so those are the civil tools. Relatively simple but very useful for civil users.